Caching can make your website run faster, it can improve your desktop applications, and it can reduce the stress in your database. Basically, if you figure out caching, you can dramatically improve how well your application scales. In this video, we're going to look at how to use Redis to quickly and easily cache our data. I think you'll be shocked at how easy it turns out to be. Now, if this is your first video you've watched of mine, my name is Tim Corey, and it's my goal to make learning C# easier. I provide videos twice a week here on YouTube to help you grow as a developer. I also have a full set of training courses on IamTimCorey.com. I encourage you to go check out all the resources I have to offer. Now, if you find a gap in the C# training I provide, and you want to see me cover a specific topic or area, please let me know in the comments below. I take your suggestions very seriously. I don't necessarily say that I will do everything that you suggest, but I definitely will put it on the list and make sure I review that list to see what I should cover next. Okay, let's jump over to Visual Studio. Now what we're going to do is we're going to create a new project in Visual Studio, and we're going to create a Blazor Server project. So let's choose a Blazor app. You'll find that in the list down here. And hit next. Let's call this Redis Demo, and we'll call this Redis Demo App. Hit create. We're going to choose a Blazor Server app. If I'm going to create a web application, by default, I'm going to create a Blazor Server app unless I have a reason not to. Now I have a whole course on getting started with ASP.NET Core that talks about the 5 different types of web projects and when you should use each. In this case, I'm going to use a Blazor Server application, but you can do this with any of the ASP.NET Core applications. You can also do this in the desktop applications. It's a little different for desktop applications, and primarily we do stuff with web applications for caching, but you can definitely do it with desktop as well. So I'm going to leave all the defaults, no authentication, configure for HTTPS, no Docker. This is just a demo. So let's hit create. And while I do stuff just because it's just a demo, so there's no authentication, there's no bells and whistles, deployment, that kind of stuff, I am going to do as much as possible to be real world focused here. So just know I'm kind of running a balance there. All right, so this is a bare bones Blazor application, just out of the box, nothing has changed. I'm going to make one small tweak, and that is I'm going to add some realism to our data. So if you notice, there's this weather forecast service, and what this simulates is going out and getting a weather forecast. Now what it actually does is just creates a random list of weather results. So what I'm going to do is, since it's just not actually talking to a data service, it's just internally getting a random list, I'm going to simulate it actually going to a database. And a database takes some time to generate data. And this is going to be more than what a normal database would. But what it will do is it will give us a good visual of how caching works. So what I'm going to do is right here after the random number, I'm going to add one line, await task.delay for 1500 milliseconds. So that's a 1.5 second delay. I need to make this async. So I'm going to await that action. Now the funny thing here is because I made this await this task, I had to change this to async, which is already returning a task of type, but because I did that, we don't have to do this task.fromResult anymore, which means I can take this off and take this off, and now I'm just returning our enumerable directly. So I don't have to do that. That basically was a hack that Microsoft did when they created this template. I don't have to do that because I actually have something I'm awaiting in here. So that actually cleans it up a little bit. But with just that one little change of adding that delay, let's see this in action just to see that delay. And again, we're pretending like this is the actual delay of the database, just to show the difference between accessing our cache and accessing the database. I'm not saying that your database wouldn't be as fast as a cache. What I'm saying is I want to show a difference. So you'll know it's accessing the database when it takes a second and a half. You'll know it's accessing the cache when it's instantaneous. That doesn't mean that the database wouldn't be instantaneous in your testing. But when you get into a real world scenario where maybe 10,000 people are hitting the database, you'll see some slowness happen. And the cache should hopefully help with that. So you go fetch data. Notice how it said loading. Let's go back and do it again. Fetch data, it says loading, and then it loads in. So you see that delay? That's our task.delay in action. So let's just say this is what normally happened with our database. Based on load, whatever, that's what it normally looks like. So you might say, well, man, our database is just getting slammed. Every time people go to this page, it reloads from the database. That can be expensive. That can be tough on the server, and it doesn't provide the best experience for users. Because when you load a page and you have to wait for it like that, that's a little frustrating. Now, a second and a half is not a big deal. But what if it was 2 seconds, 3 seconds, 4 seconds? Now you're wondering if the page is broken, and so you're hitting the refresh key, which goes and talks to the database again. You hit the refresh key, and it's talking to the database again. And that's going to mean even more hits towards the database. So we're going to implement a caching layer. Now, what this caching layer will do is these results, if this were a real weather forecast, these results would not change on a second-by-second basis. They could be the same results for a minute, 5 minutes, 10 minutes, probably 15 minutes or more. Because you notice, these are based upon days, not even hours. So it wouldn't be a big deal to have them only be updated every 15 minutes. So what we can do is we can take the results we get from the database the first time they're requested. We can store those in a different database called a cache, which is what Redis is going to do. And then we can access those results from the cache for the next, let's say, 15 minutes. Now, in our example, we'll do 1 minute. And the reason 1 minute is because it's a great short period of time for a demo, so you don't get impatient waiting for that cache to refresh and see the difference between live values and cached values. So with that, we're hitting now our cache server instead of our database server. And you may ask, well, what's the difference? There are two database servers. Yes and no. Because on our SQL database, let's just pretend this is coming from SQL, this weather forecast, we have to do a query. We have to pull data from different spots. With a cache database, we've already done the query, we've got the results, and so what we do is we store the value in what's called a key value pair. So we say, these are the weather results from this 15-minute interval. And we store that in one spot, usually in JSON data. That's what we're going to do today. We're going to store it in JSON data. So it's already in the object shape we need it for C#. And then you just pull it right back out with a key value pair lookup. So it's very, very quick. And we can scale that cache very easily. So this takes a big load off of our database servers. So let's see how we implement this in C#. Now, step one, let's close this out. Step one is actually going to be to go to the command prompt. Now, I've got a command prompt window open here. What we're going to do is we're going to use Docker locally. Now, if you haven't used Docker before, don't worry, you don't have to use it for this demo, but this is a great way to test locally for free. I really encourage you, if you are able, install Docker. It is just so helpful for demos. Because what we're going to do is I'm going to set up a Redis server. I'm going to install it, configure it, everything on my machine in 30 seconds or less. So you can't do that normally. Plus, when I'm done, within 30 seconds, I can remove all trace of it from my computer. That's the the power of Docker. I have a video on this course that talks about, Docker and how it works. I believe it's actually called SQL Made Easy or something like that, where I talk about how to use Docker for your SQL databases for a really cool purpose, like restoring your backups and providing a dev database all in one automatically. I also have a course on my site, Getting Started with Docker, where we start from the very beginning, install Docker, get it set up, learn the commands, learn how they work, and get used to this. Docker is a tool that I really think is here to stay, and it's going to be one that's already revolutionized the industry. It's very, very helpful. Microservices, it's very helpful for, in this case, demo purposes and dev environments. So really great tool. I think you should learn to use it. So in this case, we're going to set up a Redis server on our machine. So I'm going to say docker run. I'll give it a name. Let's call this, just my Redis is fine. And we're going to map a port. So we're going to say that port 5002 maps internally to 6379. Now that's the port that Redis operates on by default. You're going to say -D for detached mode, and then Redis. So what is this command doing? Well, it's going to run an image. Which image? The Redis image. Now Redis, this is going to get the latest version of the Redis image. It's going to download it if I don't have it downloaded already. I believe I do. And then it's going to operate or start that instance with a few settings. One setting is the name of the Redis container. Another is mapping the port over so we can access it. So if I go localhost :5002, that's going to be my Redis server. So, and that's internally going to map to 6379 on the internal container. Now, I could give it a username and password in order to be secure. We're not going to do that. We're going to keep this as simple as possible locally. Now, if you don't want to do Docker, we are going to, in this video, also spool up a Redis instance in Azure. Very cheap, very easy to do, very quick. And when we do that, we'll also connect to that. So if you don't want to do this, you can connect to the Azure one, but you've got to have it somewhere. So if you have a different location for Redis, cool. All you need is a connection string. That's it. And we'll talk about where to put the connection string and how to use it in just a minute. So with this one line, I hit enter. Boom, done. Now I have a Redis instance running. That's it. So if I clear the screen, well, that's not even clear the screen. I'll leave that line up there in case you want to copy it down. But then we're going to say docker ps-a for give me all the containers. And notice I have this Redis container. This is the ID of it, container ID. And the ports are mapped over and the name is my Redis. So we're all good there. So I can say actually, let's clear the screen now. Docker exec, which means I'm going to execute something on a container interactively on the my Redis container. And I'll say I'm going to implement or execute sh for shell. Cool. I'm on the Redis container, and now I can do redis-cli. Okay, so now I'm in the command line interface for Redis on my Docker instance. Notice it says 127001, that's the local host. Port is 6379 because I'm internal to my container. So now I am talking directly to the cache, the database. Redis is a database. It's keys and values. That's all it is. Think of it like a C# dictionary. So you have a dictionary with a key and a value. That's all Redis is. That's the entire database. That's all it is. So first we can say, are you really up? So I'm gonna say ping. So if you say ping, you get back pong, meaning it's up. That's all it is. Tested. Yep, I'm running. Cool. So let's select 0 meaning select the first database in my list. Okay, I select my first database. Cool. So now I'm inside the first database, and let's say DB size. How big are you? Well, 0. I have nothing in the cache. Cool. Okay. Let's do scan 0. All right. So scan 0, what it does is it says, give me the items in the list. Give me any keys and values you have. Actually, any keys you have. And it has 0 keys. We have nothing in our database yet. All right, so we're gonna leave it right there because we have nothing in the database, nothing in the cache. So now we're going to put stuff into our C# application and then use this to make sure that the stuff that we cache actually goes here, and then see what it looks like and see how our application works. So let's just minimize this. Now we need to add 2 NuGet packages. Right-click on Dependencies, Manage NuGet Packages. Go to Browse. I should have none installed right now. I don't. So I'm going to say Microsoft .extensions .caching .stack exchange Redis. Now, this is going to allow me to use caching in my web application. So this allows me to use caching, and it's using the Stack Exchange Redis version. There's a few different kinds. You can use in memory if you want to. I don't find that terribly useful except for demos. But in this case, we're going to use the Stack Exchange version. This is the most common form of Redis caching, is the Stack Exchange version. So let's install that. Accept. And then with this, we have one more package to install. And that's going to be the Stack Exchange .redis. So this is the client to connect to the actual database. So we need both of these packages. They work hand in hand to connect us to Redis. All right, so we got those 2 installed. Now let's go to our, let's go to Startup. In Startup, we have the Configure Services. And pretty much whenever we're doing an application with ASP.NET Core, we're gonna come in here and modify the Configure Services. It's almost inevitable, because you want to add things to the dependency injection system. So we're going to add our caching information to the dependency injection system. So services dot add stack exchange Redis cache, and we'll say options, and then our arrow, curly braces, and inside of here, we're going to say options.configuration equals, and I'm going to pull this right from app settings. I'm going to pull the configuration, which is a connection string essentially. I'm going to say configuration.getConnectionString for Redis. Where is that? It's not there yet. We're going to put it there in just a minute. Let's put our semicolon at the end of this line too, so we can have that completed. And there's one more thing we're going to do that it's optional, but it's probably important to do. In fact, I would almost call it non-optional. Options.instance name. What that's going to be is it's the name of your application. It's going to prepend any tag. Remember that with Redis, it's a key value pair. Your keys must be unique. So if you are shoving stuff into the database left and right from multiple applications, the odds that you use the same key in more than one application go up. Let's just say you got really sloppy in naming and you named the key based upon a person's name. That's not a good enough key. It's not unique necessarily. Let's say you call it Tim Corey. Well, what if you have that same logic in a different application for a different purpose? You'll overwrite the key from one application to the other. That wouldn't be good. So instead, what we're going to do is we're going to prepend to every key this value. And let's call this Redis demo underscore. Now what this will do is anytime, if you that key, Tim Corey was the key name you used, well now it's going to be Redis demo underscore Tim Corey. That way, if your other application, which happens to be Blazor demo, would be Blazor demo underscore Tim Corey, and you wouldn't have a conflict. So that instance name just makes it assured that even if you use the same database cache for more than one application, that you don't have a conflict. Now, internally, obviously, you have to make sure that your keys are unique for your application. But this means you don't have to worry about other applications stepping on your toes, unless they also use the same instance name, which is why your instance name should be unique. All right, so that's all the code there is here. We do need to add this connection string. So let's go to app settings. After allowed host, comma, connection strings. This is a special one, so you have to make sure you spell it right. We're going to say Redis, and the value here is going to be localhost 5002. Where did I get that? Well, remember when we created our container, we mapped the Redis port over to the 5002 port locally. Now, if you wanted to, you could have mapped the same default Redis port on your machine. That's fine. I just chose 5002 because my app uses ports 5000 and 5001, I believe. So therefore, I'm going to choose 5002. It's just totally random. It doesn't matter. As long as you don't step on toes of another application also using that same port. Just FYI. Okay, so now read from this and get the localhost value right here. So if you didn't want to use a configuration, if you weren't sure how to do that, well, if you're not sure how to do that, I've got a video on app settings that you should check out. Intro to app settings, you should know them. I also have a course on it that goes app settings in depth, that goes in a lot more depth on app settings. And we'll use one of those techniques in this video, the user secrets. Okay, that's all there was to adding our service. Let's close those two things out. Now I'm going to right click on Redis demo. I'm going to add a new folder, and let's call this extensions. And this be for extension methods. There's, you could call it helpers if you want. You could call it miscellaneous, whatever. But we're going to call it extensions for extension methods that allow us to make our lives a little easier. I'm going to right click on this and say add class. And this class is going to be called distributed cache extensions. Make sure you spell it right and hit add. So this class, what it's going to do is it's going to make our life a little easier when it comes to dealing with Redis. Now, once I show you how to do this, you can copy and paste this class. This is the most complex piece of this entire caching, and it's just copy and paste. I'm making life a little easier. And the reason why is because by default, it does not have a simple, easy map like you'd see with Dapper, where you're just saying, hey, give me a model. Instead, there's just a string data that comes back, and we're going to map that back to a full model. So we're going to have two methods in here, a set record method and a get record method. So set saves the item into cache, and the get gets the item out of cache. Make sense? Public, static. Oops, we make our class static too. So public static async, asynchronous call, task, set record async of type T. It's going to be generic. This iDistributed cache, notice it's going to add an extension, using statement up here for Microsoft.extensions.caching.distributed. There we go. There's that extension method. And we'll call this cache. And then this is going to run off the page. It's okay. I'm gonna at the end use my quick action refactoring to make this prettier, or just, well, I'll do it myself. String record ID T, which is our custom type. That's our data. Then we have time span with a question mark at the end. Whenever you see a type with a question mark at the end, it means it's a nullable version of that type, meaning it can contain null. Absolute expire time equals null, meaning I'm going to put a default value of null into it. Time span, question mark, unused expire time equals null. So these are the 5 things that we're going to ask for. Now, this is an extension method. That's why we have the this keyword in front of iDistributed cache, which means that whenever you have an iDistributed cache item, you can say dot, and you'll get the set record async method available to you as long as you have added the using for Redis demo.extensions. Now, I think I might take the .extensions off. I'm not sure. I like to have them easily available, but at the same time, I guess it kind of makes sense to keep that that whole section available. We'll figure it out. This string record ID, this is going to be the key. This is going to be what you use for the unique identifier for this cached item. That means that this can't be something that's going to repeat. We'll make sure of that. Then we're going to have the data. The data is whatever we're going to store in cache. That's why it's generic, because it could be anything. Now, in our case, it's going to be an array of model. So it's going to be an array of objects. Then we have this time span, these 2 time spans here. One is absolute expire time and one is unused expire time. There's 2 different expirations for your cached items. And what these will do is it allows you to specify what those values will be. We'll have defaults, but if we can't put a default in here, that's why it says null, because you can't specify a time span hard code, or at least not cleanly. So you can't say something like time span dot from seconds or something like that, because that wouldn't really work, because it wouldn't work at all, because it's not an absolute value. So therefore, I'm going to say null for now. So I'm going to show you these 2 values look like when we actually set this up. Var options equals new distributed cache entry options. What this will do is we're going to set up the options for the value going in. These are the configuration values we're going to give this particular entry in our cache. And this is important because we're going to set how long this item will stay in the cache. You must set these, okay? Technically, it's not required, but you really need to. You don't want things just sitting in your cache forever. Even if you're going to think you're going to overwrite them, make them expire. And then just update the expiration if you have to, but make them expire. So options.absolute expiration relative to now. That's what we're going to do, is relative to now. Equals absolute expire time, which that's this value right here. But if it's null, I don't want to put null there. So instead, say question mark, question mark. This is the null coalescing operator. What this allows me to do is say, use this value on the left, but in the event that it's null, use the next value in line. So time span from seconds, 60. What this will do, and let's give us a little more space here. What this will do is it's going to give us a default value so that if you don't give me a value for the absolute expire time, I am going to assume that you want to use the default of 60 seconds. What that means is that once you put this item in the cache, it will live for a total of 1 minute. That's it. Unless you give me a different time. So this method is going to force you to give me a time. You could say days, weeks, months. Don't. Make the cache short. Maybe maximum of an hour or a day, if depending on the data. But if you don't give me a time, I'm going to assume that you're fine with the defaults of 60 seconds. So when you put an item in the cache, if you don't give me a time, 60 seconds later, it will be deleted by Redis. You don't have to do anything. It's just gone. That's a good thing. Now, the other value here is options.sliding expiration. And I called it unused expire time. I didn't think that sliding expiration was quite descriptive enough. I'm not sure that unused expire time is much more descriptive. But the idea here is that if you don't use the cached item, let's say for giggles that we put an absolute expiration of 1 day. So 1 day, when you put it in the cache, it will expire. That's a long time. We could set a sliding expiration and say, yes, but if you're not accessing it for, let's say, 15 minutes or an hour, if you haven't accessed the data in an hour, go ahead and get new data next time they ask. So the sliding expiration is based upon its use. So if it doesn't get used within this time span, then it's going to be expired, even if the absolute expiration has not been met. Now, if the cached item is continuously used or used enough that it doesn't trip this sliding expiration, it will still expire at the absolute expiration relative to now. But that's what the sliding expiration is used for. I don't use it that often. So what I've done is I have just put in the unused expire time. Notice I did not use the null coalescing operator here. The default would be null, which it takes. It takes a time span question mark, meaning a nullable time span. So if it's null, then it's assumed not to be set, meaning there is no sliding expiration, which means we'll only deal with the absolute expiration relative to now. So those are the two options that we have set. Next, we're going to say var JSON data equals JSON serializer, which notice is in the system.text.json. So that adds that using up there for me. So JSON serializer dot serialize data. So I'm taking this data that you're passing, whatever data is, whatever shape or format it is, I'm using the serialize to serialize that data into a JSON value, which is a string essentially. And I'm putting that into the JSON data variable. Now that I have that, I can say await cache, which that's the I distributed cache, dot set string async, the record ID, the JSON data, and the options. So I'm passing in the key, the value, and any options I have, which in my case are 2. Absolute expiration relative to now and sliding expiration. And that's all there is to setting data. Yes, it looks a little complex, but all we're doing is setting options, serializing our data, and then saving. So this is what's provided with our typical caching. But because of the fact that I wanted to make it a little easier, now we have this method. So instead of just cache.setStringAsync, I have setRecordAsync. Notice I changed it from string to record. That way it wouldn't conflict. But setRecordAsync, which I pass in the model, and I have these options set up for me by default, as long as I don't want to change the defaults. And I can pass in a little more easily. So it just makes this part a little easier. I don't have to have that all around my code. Next up, we need our getRecordAsync. So public static async task of type T, meaning we'll return our type and say get record async of type T. This, let's scroll up here. This I distributed cache string record ID. Sound familiar? Oops, that was it. So let's put it in one line. Yep, that'll fit. So those 2 values, the key to look up, and it's attached to this, the I distributed cache, we'll call that cache. var JSON data equals await dot cache, await cache dot, that's better, get string async record ID. So this is going to take our key, it's going to go to cache and say, give me the string based upon that key. That goes into JSON data. Now, in theory, it goes into JSON data, because what happens if you pass in a key that's not found? For example, maybe it says, hey, is this key available? We haven't cached the data yet. It wouldn't be available. Therefore, we have to do something with that, which is if JSON data is null, return default of type T. And what that will do is whatever type we're passing in, it will return the default back. Now, that's going to be null, but this way is a generically possible or generically set up method by saying default of T. If, let's just say that our type, instead of being a normal object, like a model or something like that, we passed in int. It would return back 0 because 0 is the default for an int. So therefore, it returned the correct value. We can't just say null because by default, ints are not nullable. So that's why default T is the right value there, not just null. And finally, we're going to say return JSON serializer dot deserialize of type T JSON data. So what this is a even simpler method. What it does is it gets the string based upon the record, as long as it's not null. It may be null. If it's null, just return the default value for T. But if it's not null, then deserialize that value into the model you were given and return that value. So the get record async, we could have done this in our code, but then we'd have this to deal with still. The null check and also the deserialization. So this method just makes it a little easier by adding these things, again, in one spot instead of having to sprinkle this throughout our code whenever we deal with the cache. Let's save that. This extension methods class, like I said, you can copy and paste this into your code and it will run just fine. You could change if you wanted to the defaults for the absolute expiration. You could even move that into a central location to pull from, but I think I'm fine with it just like so for this code. That's really all the hard work we have to do. Now let's just use this in our application. Let's go over to our pages. We have that fetch data page. This fetch data page is what uses the weather forecast service. This is the one that calls that forecast service that we put the delay in. So in here, I am going to add a couple of things. First of all, at using Redis demo.extensions. Remember I said you have to add that in order to use the extension methods. So we're going to add that there. And then we're also going to inject, which uses dependency injection system, iDistributed cache, which is actually Microsoft.extensions.caching.distributed.iDistributed cache. And we'll call this the cache. Since the cache, I'm going to cut this line out and go over to my imports.razor and add the using for that so that I can just have this be shortened. It's yelling at me, but it's going to fix itself. There we go. It's all fixed. Now we're going to tweak this page a bit because right now what happens, if you scroll down here, we'll notice that the forecasts are getting loaded on initialized async. What that means is that when the page loads, it's going to load our forecast as well. But for demo purposes, that's not ideal because I don't want to keep refreshing the page. So I create a button instead that's going to load our content. That way it's very, very clear what gets loaded and when, where it comes from. So we're going to remove, we're going to comment this line out for now. Let's just comment it out, and we need to have this line right here, and this we can also put it back if we need to, but I don't think it will. So now we have our forecast, and we're going to add a couple more variables. Private string load location equals empty string. This string variable is going to store the value of where we're loading our data from. So we're going to say, hey, we couldn't find it in the cache, so we had to load it from the database. I'm going to put in that load location, we load it from the database or from the API, let's say. But if we pull it from the cache, we're going to say we actually loaded it from the cache. That way we can have a verification instead of just that delay and go, oh, the delay means from the API, the immediate means from cache. We can see where it's actually pulling from. So that's going to show us that. And then private string is cache data equals empty string. What I'll do here is I'm going to actually put a class name in this variable when we load from the cache. It's going to change the color of the text as well. So it's going to be very clear that it's coming from the cache versus the database. This is just for demo purposes to show you this. All right, in here, we're going to say private async task load forecast. This is the method we'll call from a button. So we're going to click the button and it's going to load the forecast. So first of all, forecasts equals null. And I'll wipe out the existing forecasts. That way it changes what's on the page appropriately. Load location equals null. Actually, that means we should put up here under load location, we should change that to be no default value, which by default would be null. And then we're going to say string record key. Now the record key is going to be the key in our cache. So the record key is going to be weather forecast underscore plus date time dot now dot toString. We're going to give it a string of YY, capital M, lowercase dd, underscore HHMM. What is that? Well, that's a date time string that's going to start with the 4-digit year, the 2-digit month, the 2-digit day, the 2-digit hour, and the 2-digit minute. That will allow us to create a cache value that, or a cache key, that starts with weather forecast. We know it's in the weather forecast section. Again, so we don't step on toes if we're storing a cache value somewhere else in our application. But then we're going to give it based upon the date time of hour and minute, essentially, for today. That will allow us to easily look up the value. We know what the value is going to be. So we're going to look up based upon right now, hour and minute, and find out, do we have a cache value for right now? Oh, we do? Cool, pull it from the cache. If we don't, no problem, we'll create that value and put whatever we get from the API into that value. So we'll see that in just a minute. But we're doing this since we're storing it once a minute. If we decide to store it once every hour, we could just take off the MM and we'd know that it's this hour versus the next hour. Every 15 minutes, a little trickier because you wouldn't necessarily know which minute to start on. So you have to do a little bit more work there to figure out a good key that indicates which 15-minute interval you're in. So that's up to you, but for our purposes, every minute, this is going to work great for a lookup. So now we have the key. We're going to say forecasts equals await cache dot get record async. Notice that's our record of type weather forecast array. Record key. So we have this weather forecast array that we're already using. So what we're going to do is say, well, give me that type when you look up in the cache based upon the key we just created. Now, the first time you run this, there will be nothing in the cache. So it's not going to find it. Well, if forecast is null, which means it did not find it in the cache, then we need to do our lookup, which is right here. Let's copy this and paste it down here. This is our original call to the forecast service. But wait, we're not done. Load location equals, let's do our string interpolation here as well. Loaded from API at, and we'll put the date time dot now. There we go. Perfect. So what we're going to do is we're going to paste out the date time dot now for when we loaded it from the API. This is going to do two things. First of all, it's going to tell us that we loaded from the API, meaning we did not use the cache. But it's also going to tell us exactly when we loaded it into the cache. We're going to save this to the cache. So now we can use that to go to our command prompt and look up the cache item in Redis directly to see that value. So we'll also know when that cache is going to expire. Because if we load it from the cache, we load it from the API, but the time is 1 second until the next minute, so it's 59 seconds. Well, then we know that if we hit the load button again, it's not going to load from the cache because we've already flipped over to the next minute. All right, and is cache data equals empty string? We're not going to change the color of a text. We're going to leave the color the standard black if it comes from the API. Last step here is await cache.set record async, record key, and forecasts. So if we got a null value for our forecasts, we're going to get that from the API, we're going to change our messaging, and then we're going to save those forecasts to the cache using the key we used for lookup. That key is based upon the hour and minute, not second. That's important. Just hour and minute. However, so else, meaning the forecast is not null. If the forecast is not null, we want to change our messaging. So load location equals string interpolation, loaded from the cache at datetime.now. And is cache data equals, let's do text dash danger. It's going to change the color to red. It's just some indicator of the fact that, hey, something has changed and it's from the cache now, not from the API. Okay, so we have our method to call from a button. Let's come up here to the top and let's put a button in. Button class equals btn dash primary. And we're going to say at on click equals load forecast. We'll say load forecast. Now, if I want to make this a little bit neater here, so let's do this. I'm going to change this if statement here to an else if. I'm going to say at if forecast is null and load location is, let's see, load location right now is either null or it's, okay, so it's null. So if they're both null, then do this. Well, this we're going to do is a paragraph tag. Let's put some emphasis on it and say, click the button to load the forecast. So if there is no forecast data and the load location is null, then we haven't loaded from the API or from the cache, then I want you to change this. Actually, you know what? No, that's fine. Yep, null is good. Okay, so if there's no load location, I mean, we haven't even loaded once, I want you to say, click the button to load the forecast. This is going to be an else if. So if the forecast is null, but there is a value here, that means that we're loading. So we're doing something. I know it's a bug like programming. This is why when I originally did it, I did equals empty string, not null. Because I was looking at that code going, that's not going to work. Equals empty string. Because I set it to null down here. So I set the value right here of load location to null. But the very first time I want to make sure that a load location has nothing in it. Because once you click the button, it's not going to be an empty string anymore. It's going to be null, which is different. Therefore, I fall into this case where it says loading. Now, once the forecast is not null, let's change this to be is instead of equals. Is and equals pretty much the same thing. You can use them interchangeably. So the only difference is the double equals in theory. Don't ever do this. Don't ever do this. But you can override what the double equals means or how it works. So therefore, technically is a little cleaner because it can't be overridden. But I think it also reads nicer too. If forecast is null, which is exactly what we'd say, then, so if forecast is not null, that comes down here where we actually load our forecasts. Cool. There's one last thing I want to do in here, and that is on top of the table. So let's give us a little space here. On top of the table, I'm going to create, let's do a div class of h3, meaning it's the size of an h3 tag, but it's not an h3 on the page. What that means is if you use the h tags, that's the hierarchy. That's saying it's kind of like an outline for a term paper you write in school, where you have your overall title and you have your main 3 points. That would be H1, your main 3 point, or H2, I'm sorry, your main 3 points. And then under each of those points, you'd have like an A, B, C, that'd be your H3 tags, and so on. That's very important for screen readers. It's very important for a lot of things. So sometimes when you want the size of an H3 tag, but you don't want to indicate a hierarchical difference, then you use, for Bootstrap, you just say the class of H3, which means give me the sizing that an H3 would have, but it's just a div. So little note there. And then I'm also going to say inside of the class, I'm going to say at is cache data. Now, if it's not cache data, that's going to be blank or empty string. But if there is cache data, it's going to say text-danger. It'll apply a new class to my div. And then we're going to say inside a div, we'll just say at load location. This will tell us where the data is coming from. That's it. I think we're all done. Unless I forgot something, we can get rid of this code comment now. But that should be all we need to do for caching. That felt like a lot, but it really isn't. A lot of this is just tweaking the page or setting up our extension methods. Let's get this running and just see what it looks like when we operate this directly. Now remember, Redis is up and running. There is nothing in the, it's an empty array of objects. There's nothing in the cache. Let's clear this out. So we're ready. And let's go over to the fetch data page. Now we have click the button to load the forecast. Load forecast, loading data. And it says loaded from API at, and it gives us the time. Click it again. Now it's from the cache. Notice how quick that was? And notice how the value is changing? Let's go over to Redis now. Scan 0. We now have a value here. So we can say hgetAll, and this key right here. Let's copy this. And hit enter. That's the value. Now, notice I said hgetAll. If you've used Redis before, you might say, well, why didn't you just use get? Well, get is for strings. This is actually an array because it's got multiple things. For example, this is data, and then it's got the sliding expiration date of -1, the absolute expiration of, and there's the time indicator. So there's our JSON data we're going to pull back. Now, we've probably gone past the 46 second mark. So, yep, I just loaded a new cache value. We come here and we do clear and we scan 0. We now have one entry. And that one entry is now from 19 minutes. So 1:19. But if we load forecast again, now we have from 20:10. And if I let's do clear first and then scan 0, I have 2 entries here. Now, why do I have 2 entries when we've already expired or gone past 19? Well, because we put 19 in about 46 seconds. That will not expire until 2046, meaning 20 minutes and 46 seconds. So it'll be here for a little bit longer. We'll actually have 2 entries now for a little while. But then once we get past that point, we do a scan 0 again. There we go. So now if we clear this and do a scan 0, we only have 1 entry because the second one has expired. So there's a couple things going on here. One is this cache item will now live until 2201, which is pretty close to the minute mark. But we'll only use it until we turn to 22 because we'll look for a different key. So even if you made these values last for 5 minutes, if your key is looking for based upon the minute, then you're going to get 5 values in the cache instead of just the 1 or possibly 2. So just note that you have to change the key name to match whatever scheme you're doing. But now it's very easy. I can keep clicking this button and it's never going to my API or my database. It's all working off that cache. So that's all there is to implementing caching in ASP.NET Core. Whether you're using Blazor Server, Blazor WebAssembly, which WebAssembly would be doing it probably for probably WebAssembly would be using it on the API side. So inside of your API, it'd be caching using Redis. You probably wouldn't use Redis locally because then you'd be giving away your credentials since WebAssembly runs entirely on the client. But so Blazor Server, Razor Pages, MVC, API, they can all use Redis. They can all use this caching mechanism, which really is as simple as the actual code is get the record. If it doesn't exist, load it however you would normally, and then cache it. That's the only steps you need to take in order to make use of a Redis cache. Now, I promised you that I would use Azure, so let's do that. Let's go to Azure, and I have my demos here. I'm going to show you how to create a Redis cache. So let's go to Create Resource, and under Databases, you will see down here Azure Cache for Redis. I click there. You give it a resource group. Let's give it a group of testing, a DNS name. I'm not going to create this because of the fact that I already have one, and I want to make sure that we keep this demo as tight as possible, as small as possible. So let's just say this is my Redis, something like that. And yep, that's available. So location and then cache type. You have, of course, all the different values here. Now, standard C1 1 GB cache replication. Let's look at that. Let's go to full pricing details, and you can see the pricing here. This can get expensive. So, if you decided to do F300, which, yeah, sure, that's recommended. That's $8,000 a month, US. Let's not do that. $16,000 for the F700. It's, practically F150 at that point. Let's do view all. Let's scroll down here to, the numbers look huge, but remember, this is going to save a massive amount of database computing cycles and database lookup cycles and make your websites more scalable. So therefore, this has a lot of value. And if you are a big company or you're getting hit by a lot of traffic, this will really save your bacon. So yes, there are some bigger price tags that we're seeing here, but honestly, they're worth it if you need it. But if you're just doing demos like C0, a 250 megabyte cache, which does not sound like a lot, but if you think about it, we're just storing keys and values, and we're just storing the computed data. So, for example, our weather service, that was probably a few bytes. I mean, we're not even talking a kilobyte, I don't believe, of data. So you have 250 megabytes, that'd be plenty. That's only $41 a month. That would be something you could use probably in production to get started. But let's come down even further and go to basic. So the basics down here, if we look at C0 for basic, that's a 250 megabyte cache. There is no replication. Notice these have replication for standard. Replication means you can actually have a copy of it somewhere else for backup purposes or to use as a second instance. In this case, up to 256 connections. Well, if just your API is connecting to it, not a problem. You only have one. But if you allowed users directly to connect to it, yeah, you have to worry about that. But usually for a web server, you don't have any kind of problem with this. It does use SSL, shared infrastructure, which means it's not dedicated hardware for you, and it's probably for low bandwidth, but it's $16 a month. This is a great place to start. You can scale it up. So I'd recommend C0 under the basic, which is $16 a month. Again, with Azure, you only get charged for what you use. So if you decide to follow along with this Azure demo and you create this, and then at the end of it, after you try it out, maybe after a day, you delete it, then you're paying for 1 day out of the month. So divide $16.37 by 30. So it's 1/30th of what you'd pay. So you'd pay about 50 cents for your 1 day of use. So just keep that in mind. But it is worth noting that it's not free for putting this on Azure. All right, so you hit review and create. And when you do, that's when it's going to set up and say, okay, this is what it's going to do. This is how it's going to work. And you create. But in our case, I already have one. And I'll go to it in just a minute. Okay, so we're in the Azure cache for Redis that I created previously in order to do my testing on it. And this is what it looks like. So you can go here, and the most important thing, I'm not going to show it to you because this is actually secret information, but if you click on CS keys here and show keys, it's going to give you connection strings to this Redis. Those connection strings will include a login name and password. That will ensure that only you have access to this cache. Now, the other cool thing is right up here we have console. Click that, and now this is the console. You can say ping, you get the pong back. So we can do things like select 0 for that 0 database. We can say scan 0 for, hey, what's in here? In this case, we have an empty cache. There's nothing in this. Now we can go over to our code. Let's go back to our code. And in this code, I'm going to add a secret. So we have our app settings.json, which has a connection string for Redis, and that's localhost. But I want to use the Azure cache instead, but I'm not going to give it to you. So I'm going to go to my Redis demo. I'm going to right click and say manage user secrets. This opens a secrets.json, which in here I can say connection strings. And this is Redis. And I can put the value, which I'm going to do. I'm going to save this and close it. I'm not going to show it to you. Okay, I decided not to close it yet. I want to show you this is what it looks like. It starts off with the path to Redis and then the port number on Azure. And then it has this password, which that's behind. That's why I opened a Solution Explorer so large. It's behind Solution Explorer, but that's I just copied and pasted from what Azure gave me in that first page. So you put that in secrets.json. Now it's not part of the project, meaning this file is not located with the rest of my project. It's located on the app data roaming Microsoft user secrets, and then a GUID, and then secrets.json. But this is associated with my project just on this machine. So when I give you a source code, you're not going to find secrets.json. It's not going to override the localhost 5002 with my Redis information. Instead, this is going to be just for me. So we will override it. It will go to Azure. We're going to prove that in just a minute, but that's the only change I'll make to my application. Just that one override of the connection string. Let's close that out. So we're not going to use localhost anymore. Now, secrets.json overrides the values found in appsettings.json. We talked about that in the intro to app settings video, as well as my app settings in-depth course. Let's bring us back to a less ridiculous size. Let's run this again, and we'll verify it's putting stuff in the cache, which it should be. Load it from the cache. I'm sorry, load it from the API. Now load it from the cache. I wanted to just verify one other thing too, or show you one other thing. And that is, let's shrink this down a little bit. Let's copy this. I'm going to open up Firefox. This is Firefox. Let's put this in another window and shrink this down. Actually, I'm going to shrink it down this way too. I'm going to paste in this value. In Firefox, with the certificate, is going to say, hey, that's a problem. Just say advanced, accept the risk and continue for this particular thing. Let's go to load forecast. Notice it loaded from the cache, even though I hadn't loaded it over here, because it's pulling from the same cache. It's pulling from the cache that this page created. Let's open up Edge as well. Edge is actually a Chromium, but let's go over here and paste and go to that location. We're gonna load, and now it's pulling from the API because our time has expired. But if I go back to my Firefox, it still pulls from the cache. I go over to my Chrome, it still pulls from the cache. So these three aren't connected directly. It's just they're using the same Redis cache. Let's go over to our window over here in Azure. Let's go scan 0. Notice we have something in the cache now. Let's copy this, and we'll say hget all, and the key, and there's our data. So this is on Redis, on Azure. So we're now using Azure as our place to store data. So let's clear it out again, and let's do a scan 0. We only have one. We probably, yep, we're loading a second one here. So now if we go back real quick, we can see, oh, the other one expired. So you gotta catch them real quick in order to get 2 in there. But now it's the newer value. So that's how you look at or work with the console inside of Azure to see that same stuff. And notice there's where we're hitting the cache and how that's working. So that's how you use Redis, whether it's locally using Docker. And let's just finish this out here by going back to Docker and scan 0. You'll see nothing in there because we haven't been using it recently. But we can say exit and exit one more time to get back to our command line. And we can go to docker ps-a to see that we have one container running. So I'm going to say docker stop 6f0. Notice that's the first 3 characters of our container ID. It's going to stop that container, and then docker remove rm 6f0. Removes it. So now docker ps-a gives us no containers. So we've removed Redis from our machine. That's it. That's all it was. To uninstall Redis was just to remove that container. Now, if we do a clear, we do docker images, you'll see that the, let's expand this out here. I have 3 images on my machine. RabbitMQ, you're gonna see that pretty soon. Redis, and then ASP.NET Core. Those are the 3 images they have. That means there's 104 megabytes on your machine for Redis the image. That'll make it easier next time you want to bring that back and create a new Redis image. It'll be faster than downloading that whole 104 megabytes again. But if you want to get rid of that, you could do docker RMI and then the ID for the image, which in this case would be BD5. I'm only using the first 3 letters because it's dissimilar from any other image. Now notice BD for the ASP.NET Core one as well, so I couldn't just use a 2. That's why I use 3, because the chances of 3 being the same between 2 different ones is pretty low. If it were, just add the 4th character and you're probably fine. So I'm not getting rid of it because I want to use Redis again. I love using Redis. It's easy to use. For Azure, there's 2 ways to get rid of this. One way is just to go into the Azure cache for Redis and hit delete. But if you do that, you might leave a resource group out there hanging. So I like clicking on the resource group. I created this resource group just for testing the Redis. And therefore, I only have one thing in here, Redis. But sometimes you create a website, it might create a website and also creates a web host kind of thing and maybe some other stuff as well, maybe some storage or something else. If you use the resource group, it's going to tag them all here. And now you can go to delete resource group, which will delete everything in the resource group. In this case, just the one item, the Blazor test Redis. So delete resource group, and you can just copy whatever's in the quotes here and paste. The idea here is just verifying that you really do want to do this by making you retype it, because once you delete this, there's no coming back. You can't get it back. There's not an undo here once you hit delete. So please, please, please verify what you do. I'm saying this from experience. If you don't, you will delete something that you regret. I have done this. I have deleted an entire development environment that I had to recreate painstakingly because I didn't have anything automated set up. So be very careful. Hit delete. That's going to take a little bit, but once it does, it's going to delete the resource group and it's going to delete the Azure cache for Redis. So that's how I clean up Azure. That does mean that now that I hit load forecast, it's going to say loading, and at some point it's going to do this, and then it's going to fail. And once it fails, what will happen is it'll throw an exception, and it will no longer be able to access Azure. So it's taking a little bit. I guess it's taking a little while to finish the delete process, but at some point it's going to crash. I think it's just crashed. So once it does, yep, you get unhandled exception. You can get the browser tools, F12, go to the console, and this message right here, if you can see it, let's kind of zoom in. Console's not very big. Let's make it bigger. There we go. Timeout awaiting response from the Redis. So what it's saying is, I couldn't find Redis. Therefore, we got a problem. And that's where you go, oh yeah, I don't have Redis turned on, which is one of the things I did during testing. So I want to show you that. So with that being said, that's how you use Redis in order to add caching to your web applications. Like I said, you can use this for desktop applications as well. It's a little trickier. I would personally say that you'd probably want to use an API and use the Redis there rather than trying to use it directly in a WPF or WinForm application, but it all depends on your use case. So Redis, really, really powerful. It's going to make your application scale a lot more because you can scale Redis much more cheaply and much more globally than you can the rest of your infrastructure. So any place where you have data that does not have to be all the time updated. And this actually is a lot more places than you think it is. Because at first you go, well, there's nothing I would ever use this for except maybe some combo box dropdowns. That's not true because data doesn't always have to be up to the second. I want to prove this to you I'm going to do two different things. First of all, let's go back to the browser and let's go to two different sites. The first that we're going to go to is Amazon. And let's just Epic Deal a Day Catan. Great game, right? And it says, is it in stock? It says, yes, it's in stock. Usually ships in 6 weeks. Not a greatest example. Ticket to Ride Europe. There you go. In stock. How do they know? When I came to this page, did Amazon go and check the stock and do a query on it and say, oh, yep, it's in stock, and put this on the page? No, they didn't. They actually are using a caching system for this value. In theory, this could be out of stock even though it says in stock because the cache hasn't been updated. And they don't update the cache immediately. It takes a little time. They have spaced out that time appropriately. Now, I don't know what that timing is, and I think it might be a sliding scale based upon interest in the item. I'm not sure. But every once in a while, it's very rare, but every once in a while you'll get I'm sorry, couldn't fulfill this order. That means you ordered something that said it was in stock, but it's not really in stock. So that's one area where it's close to real time, but not real time. So at some point, these cache values are updated, probably in the background, but they're updated once for the entire organization, and then that cache is what gets hit over and over and over again every time someone looks at Ticket to Ride Europe or whatever thing they're looking at on Amazon. So that's one area where caching is really useful. It allows Amazon to function. Amazon would not function at the level it does without caching. Another interesting one that came up recently, if you're not familiar, and probably the whole world is at this point, I'm sorry, but the US is going through or just finishing up an election process. And I found it fascinating. I didn't see this on all the sites, but I did notice on one site. I bounce around. But if you go to CNN and go to this map thingy here, actually it's even down here. Let's see if we can zoom in. Yeah, there we go. So if you zoom in on, say, President battle for Pennsylvania, cool numbers, woohoo. But if you look down here, estimated percentage, 96%, but then updated at 10:41 p.m. Okay. And then there was at one point, I'm not sure if it's here or if, let's zoom back out. There is, let's go to the map. There's one spot where I noticed that there we go. Next update in. So it's every 10 seconds they update this thing here. Now, new election numbers, new votes don't come in every 10 seconds. But what they're saying is this is cached data for 10 seconds. Because it's such a last minute thing, we want to make sure that you have up-to-date information, but at the same time, you don't need information every second. In theory, the numbers could have updated and you'd wait 10 seconds to find out. That's not a lot of time. But what that allows CNN to do is update the numbers once, put them in a cache, and then have everyone access that cache. Because for Americans at least, if not the rest of the world, there's a lot of people coming to this site. I can imagine how many hundreds of thousands of people, millions of people are coming to CNN.com. That can bring a website to its knees. And so they're using caching, and they're even displaying openly the fact that it's cached and when it's going to next be updated. So this is just another instance where we see caching in use. Okay, so I want to kind of point those out. Think through your own applications and think through, hey, when can I use caching? It's probably more often than you think. If you're doing any kind of displaying of data or any kind of query where you're hitting the database a lot, that's a good place to look at caching. It doesn't have to be for long, but maybe a 1-minute cache or a 5-minute cache or 15-minute cache. For example, most applications, when they first start up, they load some kind of starter data. Maybe it is the, the calendar. And so it shows all the events happening today. Well, how often do you need to update that? Once every 5 minutes probably is enough. Well, if you have a company of 1,000 people that are all loading your application up and they're all hitting that calendar, that's 1,000 times that calendar gets hit every time they open their application up or go back to the home page. Which, if it's the home page, they're doing it a lot. Therefore, cache that every 5 minutes for a 5-minute time period or even a 1-minute time period. And what will happen is you'll reduce the load on your server. You'll do that query less often. You're doing it once a minute instead of 1,000 times a minute. Your SQL Server will thank you. So that's caching. Redis, very easy to use. You can find out more information. Go online, Google Redis, and you'll find out tons of information. But that's really all there is to using Redis in your web application, is just install or get Redis set up somehow. I love Docker because how quick that was, or Azure Redis because it's available on the web and production ready. But either way, connection string, bring in this static class, and then just set up your calls like we did here, where we just said, hey, get it from the cache if possible. If it's not there, put it in the cache, and either way, you're done. That's it. It's getting set. Okay? Let me know what your thoughts are on Redis. If you have any questions, put them down in the comments below. I'd love to hear your thoughts. I appreciate the thumbs up for the video. I appreciate you watching this long. Hopefully you get a lot of value out of Redis and really can take your application to the next level. Thanks for watching, and as always, I am Tim Corey.